Our universe is full of captivating celestial events that leave us in awe of its vastness and complexity. And one of the most fascinating of these events is the Great Conjunction of Jupiter and Saturn. On December 21, 2020, stargazers from around the world witnessed a once-in-a-lifetime event as Jupiter and Saturn appear to align in the night sky. This rare celestial phenomenon, also known as the Christmas star, captured the attention and imagination of people everywhere. In this video, we'll explore the science behind the Great Conjunction, and we'll take a closer look at why this event was so special. From the planetary orbits to the fascinating history and cultural significance of this event, we'll cover everything you need to know about the Great Conjunction of Jupiter and Saturn. So get ready to be transported to the depths of space as we explore the wonders of the universe and uncover the mysteries of the Great Conjunction. But before we continue, subscribe to our channel now and ring the bell icon to never miss any updates from us. With that being said, let's dive right in. When Jupiter and Saturn are closest to one another in the sky, this is referred to as a grand conjunction. Every 20 years, when Jupiter overtakes Saturn in its orbit, there are large conjunctions. These are known as great planet conjunctions because they are quite uncommon to see with the naked eye. With most instances falling between 0.5 and 1.3 degrees, the distance between the planets fluctuates from conjunction to conjunction. Separations of fewer than 10 arcminutes have only occurred 4 times since 1200, most recently in 2020. Extremely near conjunctions occur far less often. Skywatchers were set for a treat at the end of the year 2020. In the next 2 weeks, the brilliant planets Jupiter and Saturn will join together, culminating on the night of December 21, creating what has come to be known as the Christmas star, an unusually colorful planetary conjunction that is readily visible in the evening sky. Galileo Galilei, an Italian astronomer, used a telescope to survey the night sky in 1610 and found Jupiter's 4 moons, Io, Europa, Ganymede, and Callisto. Galileo also saw an odd oval around Saturn in the same year, which subsequent studies confirmed to be its rings. These findings altered how people thought about the furthest limits of our solar system. The 2 biggest planets of the solar system, Jupiter and Saturn, moved across the sky together 13 years later, in 1623. A great conjunction, as it is called in astronomy, is when Jupiter overtook and passed Saturn. Henry THROOP, an astronomer in the Planetary Science Division at NASA headquarters in Washington, described the solar system as a racetrack with each planet acting as a runner in their lane and the Earth positioned near the middle of the stadium. We'll be able to observe Jupiter in the inside lane as it travels towards Saturn for the whole month, until ultimately passing it on December 21. The locations of Jupiter and Saturn are aligned in the sky around once every 20 years, with the planets seeming to pass each other often throughout the solar system. Over 800 years have passed since Saturn and Jupiter lined up in the same constellation at night, as they will in 2020, making this great conjunction visible to almost everyone on Earth for the first time in nearly 400 years. The closest alignment, which lasts a few days, will seem to be barely a tenth of a degree apart. On the 21st, they will be so close together that your pinky finger, extended out at arm's length, may easily cover both planets in the sky. Looking southwest right after sunset made it simple to view the planets with the unassisted eye. While the enormous gas giants were initially hundreds of millions of kilometers apart in space, they looked to be quite near to one another from our vantage point on Earth. The timing of the conjunction, which occurred on the same day as the winter solstice, was purely a coincidence based on the planets' orbits and the Earth's tilt. According to the positions of the planets in their orbits, conjunctions like this one might occur on any day of the year, according to THROOP. The locations of Jupiter, Saturn, and the Earth in their orbits around the Sun define the date of the conjunction, while the tilt of the Earth's axis determines the date of the solstice. People will have a fantastic opportunity to walk outdoors and see the solar system, since the solstice is the longest night of the year due to this unusual coincidence. Great conjunctions drew a lot of attention as omens throughout the late Middle Ages and Renaissance. Translations of Arabic writings, particularly Albumisar's treatise on conjunctions, were found to be the source of this fascination. Although astrologers disagree regarding the origin of trigons and there were mathematical mistakes, trust in the importance of such occurrences led to a steady stream of writings up to the end of the 16th century. Because of its position in the water trigon, the big conjunction of 1583 was generally believed to portend cataclysmic events. But when nothing substantial occurred by the predicted event of 1603, however, popular attention quickly waned. By the beginning of the next trigon, astrology had long been discredited by contemporary science, and planetary alignments were no longer seen as bad omens. Every 19859 Julian years, there are one or more great conjunction seasons, each of which it is 365.25 days. Jupiter and Saturn have synodic periods of 72, 53, 46 days, or around 52 days, less than 20 years. Due to the magnitude of Earth's orbit, grand conjunctions might occur again anywhere between 18 years and 20 years and 8 months after the last one. The most recent great conjunction took place on December 21, 2020, while the next one won't happen until November 4, 2040. The two planets were 6 arcminutes apart in the sky at their closest during the 2020 grand conjunction, which was the closest separation between them since 1623. The proximity is a consequence of the conjunction happening near one of the two longitudes where, as seen from the Sun, the two orbits seem to cross. The longitude cycle follows a triangular pattern, with the triangle's 3 points rotating about 1/6 of a revolution every 4 centuries in the same direction as the planets. The current longitudes of near-great conjunctions in the constellations of Capricornus and Cancer are 307.4 and 127.4 degrees, respectively. The planets may seem up to 10 degrees in front of or behind their heliocentric longitude, depending on where Earth is in its orbit. Jupiter's orbit plane is inclined 1,303 degrees, whereas Saturn's is inclined 2,485 degrees concerning the Earth's. Since both planets' ascending nodes are similar, Jupiter will often be above or below Earth's orbital plane if Saturn is. When the planets were inclined farthest off of the plane in 1306 and 1940, the greatest conjunction distances were 1.3 degrees. Among the most significant occasions of the great conjunctions are the Grand Conjunction of 7 BC, as seen from Jerusalem on the evening of November 12, was recreated. Johannes Kepler hypothesized that the Star of Bethlehem may have been the result of a big conjunction when researching the Great Conjunction of 1603. Using astronomical year numbering, he determined that a triple conjunction of Jupiter and Saturn took place in 7 BC. Jan Masenius, Stanislaw Jakowicz, Nicholas Jedek, Petrus Probasiewicz, and other astronomers from the Krakow Academy watched the Great Conjunction of 1563 to contrast the Prutenic tables with the Alphonsine tables, which were based on a geocentric model, based on Copernican heliocentrism. Astronomers discovered Jupiter and Saturn to be so near to one another in the Prutenic tables that Jupiter covered Saturn. Actual angular separation was 6.8 minutes on August 25, 1563. The Alphonsine tables recommended waiting another day to see the conjunction, but on the day they recommended, the angular separation was a full 141 minutes. The Krakow academics recommended adhering to the Copernican forecasts, since they were more accurate, and Valentin Fontani gave 3 lectures on Copernican heliocentrism between 1578 and 1580. Tycho Brahe also spotted this conjunction and noted that the Copernican and Ptolemaic tables used to anticipate it was off. This made him realize that advancement in astronomy requires methodical, meticulous observation carried out night after night, using the most precise tools available. Jupiter and Saturn separation just before the 2020 Great Conjunction. At a minimum distance between the two planets of 6.1 arcminutes, the Grand Conjunction of 2020 was the 7th closest of the first 3 millennia AD and the closest since 1623. The best near conjunction since 1226. This stellar alignment was also the easiest to view, as the previous close conjunctions in 1563 and 1623 were closer to the Sun and therefore more difficult to see. It took place 7 weeks after Jupiter and Saturn's heliocentric conjunction, when their heliocentric longitudes were identical. On December 21 at 1820 UTC, Jupiter was 0.1 degrees south of Saturn and 30 degrees east of the Sun, marking the closest separation. This indicated that both planets were visible simultaneously across the fields of most small and medium-sized telescopes, though they were distinguishable from each other without optical aid. Both planets seemed to be a binary entity to the unaided eye at the closest approach. 1 hour after sunset, at a height of less than 15 degrees above the southwest horizon in the constellation of Capricornus, the planets were visible from mid-northern latitudes. The closeness of the conjunction's timing to Christmas, and the fact that a great conjunction is one of the theories for the biblical Star of Bethlehem, both contributed to the conjunction's widespread media coverage, earning it the moniker Christmas star, according to news reports. The Great Conjunction of 7541, which is also a triple conjunction, is anticipated to have 2 occultations, one entire on June 17 and one partial on February 16. Other estimations of planetary locations, however, anticipate extremely near conjunctions in 7541 rather than occultations, since the precision of planetary positions this far in the future is exceedingly unclear. Since 6857 BC, there hasn't been an occultation between the 2 planets. Superimposition necessitates a distance of no more than 0.4 arcminutes. So, that's a wrap for today. Did you manage to capture any photos of this incredible event? What other celestial events are you looking forward to seeing in the future? Let us know and share your views with us in the comments section below. Also, make sure to subscribe to our channel and ring the bell icon for more exciting space news and discoveries. See you soon in our next video. Thanks for watching.